All right. Well, I know we've got a lot of people so far. We've already got, it looks like around 54 folks on live, and folks are still coming in. So we'll just do a few minutes intro here, and just wanted to let everybody know we're going to try to keep like the formal presentation part about OpenMine.AI to wrapping up around 12:30. And if you added the meeting through the LinkedIn event, it's probably that's what it put on the calendar, but we can stick around for later. So we'll do Q&A after that as well. So just another reminder for folks that are just coming in, you can submit questions, anything you want to see, any follow-up stuff. This is just a first look. So feel free to submit it here, or you can go to OpenMine.AI and you can fill out the form that's down at the bottom of that page, and we'll set up an actual demo and give you some more specific information, customized to what you're looking for at your company and with your team. So with that, I'd like to welcome Mark and Andrew from our partner company, Striveworks. If any of you stopped by and said hello at our booth at PDAC or came to our Mining Futurist party, you might have seen them around. We're really excited to be partnering with Striveworks on a new product and platform at Prospector called OpenMine.AI. And if any of you have ever worked with large volumes of legacy data, or wanted to just say like, okay, what's every reference for a certain project in all the data that our company has, something super simple like that, going up to, we've heard folks say, I want to pull out every flow sheet diagram that's ever been used for a specific commodity and everything we've ever done, any of those types of use cases, OpenMine.AI is for you. So I just wanted to kind of tie it back a little bit. I know it looks like we've got a lot of folks on the call who are geologists and have worked in the exploration space and are also at active mining companies. And I think what's really important about what we're doing is really finding that hidden value in your existing data, right? So OpenMine is a platform and a tool by which you can go into all of your existing data and documents and query it, right? And you're going to see John and the team show you a little bit. Basically, it looks like a ChatGPT interface. For me, I go back to when I was running that program in Afghanistan that a lot of you all have heard about. The first thing we did in Afghanistan as a team was digitize all of the kind of old legacy data from the 1970s that was collected by the Afghan Geological Survey and the Soviet geologists, along with a lot of other groups. Digitize it, protect the data, get it into modern data types and structure so that you can then leverage it using all of the modern stuff that we have, which at that time was like, just let's get it into GIS, let's get it into the ability to go in and find the documents however we need to. Now we can kind of take that to the next level. So really excited to share this all with you because, again, whether you're an exploration company, a mining company, a consulting or technical services company, or you're looking to sell products and services into the industry, what you're going to see today can all be applied to your proprietary and internal data. So the team's going to show you the tools that we've built and how we've applied it to public disclosure documents, because as you know, that's what Prospector's platform is really built off of. If you go to prospectorportal.com and sign up for a trial for analysts, that's all pulling from public disclosure documents, technical reports, press releases, financials, all that good stuff. So we're going to show you how the tech works on that, but it can all be used on your data. And we can tell you more about that if you go to OpenMine.AI and fill out that form, and we can kind of take you through what that looks like. So with that, and I've had a bunch of Celsius this morning, I will hand it over to you, John.
All right. So OpenMine.AI. So again, really happy to have our partner Striveworks on the call with us today. Really, and what we're talking about is mining data simplified for a resource-powered future. And really, for us, Prospector as a business, we really focus on how to use AI to curate and extract information from large volumes of documents, most notably public filings. And really, this involves really sort of 4 categories of steps, right? And these are all things that relate to the way that we think about OpenMine.AI as we are conceiving it and building it and putting out there in the world for folks to use. So one is you have complex data. There's like PDFs, there's geospatial files, there's images, there's all kinds of stuff that's out there. You got to pre-process that and you got to curate that. You got to do some sort of human-centered AI extraction. You got to validate those data sets, make sure they're annotatable, and then you got to distribute it somewhere, right? And so for us, this typically involves us taking in public filings. We use a lot of AI tools to extract key points and information. We organize that and curate it, and then we put it out via our SaaS platform, our analyst product, or we do it through data feeds or insights reports that we send to our customers. And we specifically focus on leveraging a technique called human-centered AI. And what this means is we don't let the AI just go out through the PDFs, extract some information, put in a table, and do something, right? Maybe AI will get there at some point where we can trust it to do that, but really it's not at the level and still requires some human interaction. But what we can use it for, we can use certain techniques to really reduce the amount of time it takes an analyst to actually extract information. And we call it human in the loop AI, right? So we're always using this, and we're always focused on, if we're going to try to categorize a document to a project, if we're going to try to pull out some resource and reserves that we want to tabulate, or a life of mine plan, or productions data, we're using the AI to kind of predict that, have a human review it and validate it, right? Or and as confidence grows, find ways which we can increase and improve some automation, but always putting a human at the center, right? Looking at that from how we do analysis. And going through the process to do this, right? First, we got to take all those documents, we got to put them together. We have to pre-process them somehow. We then have to run them through some AI models, and then we get our extractions out. The problem with this is, one, there are many, even from a public data standpoint, there are many data sets out there held by various stakeholders that need to be aggregated. You have to normalize those things so that you can actually effectively use AI models. And then oftentimes, just executing those models for any one individual organization, it can be cumbersome, right? Just to put the infrastructure in place. And then even the platforms that do exist out there, they're very technically focused, right? So sometimes it makes it very difficult to even manage or train or use a model if you are not someone who can write Python code or something of the like. And so this is where really the thesis behind our partnership with Striveworks and our OpenAI Mine approach, right? So one is centralized and curated access to publicly available data, paired with pre-processing tools and support, right, to help organize that data. And then base models focused on the geology context, right? Models that can be applied specific to mining and geoscience to extract insights. And then bringing in a best-in-class platform from Striveworks as part of the application that allows us to then run the different machine learning and natural language processing ops we want to run to extract the insights that are most meaningful to you and your organization. And really, this is where we get, right? Combine public data, leverage NLP and computer vision models to go through that data and categorize, extract information, test and experiment in an MLOps platform that's everyone can access, not just data scientists, and really resulting in identifying more opportunities, creating cross-functional data insights, and managing data and models at scale. And this is kind of a view of the sort of platform we are now, I would call it kind of an alpha stage that we're working through, right? Where there's a series of pre-processing tools, things like image indexers, creating embeddings out of text, extracting text out of PDF documents, different models, whether those be things for summarizing the documents, classifying certain things, extracting images, and then coordinated and consolidated data sets that can be then shared, all partnered with a workspace where you can then interact and work with this data to create meaningful insights for your organization. And I'm going to hand it over to Mark. Oh, sorry, I have to go through a bit more. I'll hand it to Mark in a second. So what this results in is data centralized curation, right? So our initial focus here is public filings, assessment reports, drill core logs, geospatial information, really putting it in one place where you can access it and use it. Providing pre-processing tools. Every time we get a document, we store the metadata on that document, we extract the text, we store that document somewhere, we extract the image so we can do computer vision techniques on that document. And so what we're putting out there is ability to use some of these models that we use ourselves on your own data or on the data that we have already, right? And allow you to kind of come up with your own use cases. And then use of our other models, right? So we have models already that do things like figure out who the QP is on a technical report, what minerals does a report talk about, where is it located, what stage is it, what is there a publicly traded company's project that we already know it exists with, what are the deposit models, what are the mining methods or processing methods associated with it, what are the things that we need to collect with a human intervention, can we figure out things like capital expenditure, those things. So these are all models that we actually actively use today to do our data extraction. And they're models which we intend to make available for organizations and others to use on their own data sets or to apply them into our data in a way that we haven't even thought about yet. And then this gets to where I'm going to hand it over to Mark to talk about the MLOps platform that comes into this process.
Thanks, John. So the big thing here, with Striveworks is we're very focused on both structured and unstructured data and trying to be able to extract insights from this. So what that looks like, for a mining company that's been around for 50 or 100 years is you have a bunch of digitized documents that you need to basically pull insights from, whether that be drill results or images of maps. And so what Striveworks is purpose-built for is unstructured data and structuring that data so that you can query it in a meaningful way. I think the second piece that John has touched on a bunch is like we're trying to connect both public information that you have available as well as your proprietary data, but also ensuring that this is a secure platform where you're not asking an open source AI platform or LLM like ChatGPT, where you have to upload your documents to something that you no longer own. This will actually sit within your own proprietary infrastructure so that those documents never leave. So there's no concern of that data being released out into the public. The next piece here really is the ability for us to design custom models on top of the prepackaged models that you may have. We provide a very simple platform for a low code, no code UI that will allow your subject matter experts, say your geologists, to actually come in here and annotate data in a simple capacity that an 8-year-old can really do. And the idea there is you actually leverage where your expertise lies, which sometimes is outside of where your data scientists may sit. And so it's democratizing the use of this platform and allows everybody to be involved in basically garnering the insights necessary to analyze that data that you have and get value out of it.
All right. Thanks, Mark. With that, we're going to actually dive into some use cases and things that are already out there. I'm going to just pop out of the presentation and share with you all our language model, one of our language model setups that actually goes through and analyzes drill results. And so here you can see on the map, these are all the drill results that happened in the last 24 hours from the public filings that we track. And I'm just going to ask a question. Let's do, looks like there's some intercept results for Celebi mines. And so tell me about Celebi mines results. And what this does is this language model then works on top of the publicly available data, comes and provides a little insight. So if you're trying to keep track of lots of different projects and such, you can actually use the language model as a tool and assistant to do some of your analysis. And as it comes back, it's actually pulling directly from the filing itself. And it's been trained to always bring back some sort of link to where that document comes from. And right here, I can open up and I can go to the filing. And you can find it right on Prospector. And you can go and read through the details you want, or you can continue to ask the AI more questions. So maybe I said, give me an assay results table for the Celebi mines projects. And it's going to go through and it's actually going to get the holes from the document, and it's looking for the highlight results and bringing back the grades and estimates so you can look at the interval as well as what's there. Again, really trying to make it so you can look through more filings at once and use it as an assistant for yourself. Our analysts use this all the time for things like asking questions about what's the CapEx and such and trying to find the page where it's located on. these are ways in which we shorten the way we do analysis. And what we intend to do with OpenMine.AI is to actually make these available for your own type of analysis, so you can openly use this to do your different discovery. So, and if I wanted to, we can ask about another one. So, tell me about what's MacArthur. This is one of the other ones here. And it's now we're going to do some research, and it's going to tell me about that project as well, right? So excited to share this. We are looking for some beta testers to test this out. So if you are interested, please include that in your form. We'll get you set up, and this is something that will be probably integrated into our end production application at some point in the next month or two. But it is something where we're sort of testing out before it goes the length. But it is one of those things that part of OpenMine.AI is to make this available not only to sit on top of the public disclosure data we have, but also to go through and for your own data if you like, right? So you can host it on your own infrastructure, and you can use it to analyze things and use it as part of your own workflows inside your company itself.
Yeah, so John, just to clarify, so this would be a tool, if you imagine this for your own internal data, maybe you've got multiple projects within the company and you want to maybe even look historically, right? What were the drill results several years ago at such and such project while we were doing step out drilling, right? And it allows also for that cross-team collaboration as well once this type of application goes across your internal data, right? So exploration team, production team, investment team can all check that out.
Right. And so I'm just going to pop back into the presentation and let Mark talk about some of the other stuff we've been working on.
Yeah, so I think it's obvious Prospector is a pretty well-known entity within the mining space, and probably Striveworks a little less so. And so I want to just give a little background on what Striveworks is and where we come from and why we're kind of purpose-built for the application that we're developing for OpenMine.AI. So as I mentioned before, structured data is kind of like Lego blocks. Things fit together really well, whereas unstructured data is more kind of like clay. It's very easily manipulated into different scenarios and much harder to run machine learning on. And so it's important just to call out that 85% of enterprise data is unstructured. And so in order to get insights out of it, it is important to structure that data. And that is really what Striveworks was purpose-built to do. We're an end-to-end platform, so it allows for data science teams to basically have a singular platform. You can think of Google Drive, for example, as a comparison, having all your data scientists and all your team members in a singular platform managing all those models. And then I think the biggest thing here, which may be less understood, is that 91% of all models actually fail because they were built yesterday off of, the last year's worth of data or the last 20 years worth of data, but the world is dynamic. And so in order to make consequential decisions for our customers, we incorporate the ability to what we call remediate those models, to update those in real time, to self-heal them. Dr. James Zhao out of Stanford did a study on all the LLMs, and they're actually degrading over time, with human interaction. And that will occur as well with any model that you develop. Just due to that human interaction. And so it's important for you to be able to understand the drift of that model and ensure the inference level is at a point of which the business is comfortable making a decision off of. You don't want to go just make a determination to acquire a mine off of ML model and find out that the inference rate is at 60%, which would be like basically barely above random selection, right? So we want to make sure it's above a 90% inference rate. And so it's important for us to be able to look at those models. In terms of, what you get with Striveworks, the key thing to call out here is there's a ton of different types of models, the LLMs, the NLP functions, computer vision, and the ability really to combine the data that Prospector already provides you from publicly available sources, but then also now being able to incorporate all of your legacy enterprise data that may be sitting in a bunch of different formats and be able to extract insights from that. We can also integrate this into existing workflows. So if analysts are using ArcGIS, for example, it's easy to integrate these models that are actually populating that data directly into those workflows as you need it, to where basically you're disappearing the MLOps function, to an end user, which is super important. We have a ton of expertise internally, PhD data scientists and ML engineers to support these use cases for customers. So, depending if you're a 0 on a 10 on your AI journey or a 10, we meet our customers where they're at in that sense as well. And then it really is important, this is not some high code platform that no one can use unless you're, L5 engineer or ML engineer. Like, you have the ability to do this if you're just a traditional user trying to get involved in leveraging your expertise in the application or the use case to interact with your development team to ensure that those models are accurately providing you the insights that you need. So we've developed it to where, you can actually annotate images with AI that automatically determines, what is what within, say an 80-page document, and then automate kind of the inference and capture store as well. But then if you're a mature data science user, you can do all of the things that you need to from a high code perspective, leveraging things within Jupyter notebooks or Python code, however you wish to deploy it in that sense as well. And I'll be handing the mic over to Andrew to kind of walk through some of these examples of what we're looking to develop for OpenMine.AI.
Hey everyone, my name is Andrew. I'm a solutions engineer here at Striveworks, and I'm just going to be briefly walking through one of the projects that Striveworks has actually been working on, which is extracting maps from large volumes of PDFs and then being able to place those, which is something that we've heard as feedback from people that we've talked into the mining community saying, hey, I have these gigantic legacy documents and really I only care about these parts here, these maps, and how do we take those out and actually turn that into something that's useful for people in the mining industry? So we built a workflow that goes through documents, extracts various text from them, extracts the images, classifies them, and extracts the lat longs, and then puts that into a clean searchable database, which we're able to geolocate and place on a map layer somewhere. So John, can you go next slide, please? So the first step of this was we used our MLOps platform to build a map detection and extraction model. So what this does is it goes through those PDFs and says, hey, okay, this looks here like a drill core, or this is a geophysical map or otherwise. And it's able to take that, classify it, and crop it so that we get only the part that we care about. And we go ahead and store that with labels that are associated. One of the difficult problems that we ran into is a lot of these PDFs are old legacy documents. Imagine something that's been scanned multiple times even, so 5, 10 times over the time. And we're seeing hey, the PDF has really degraded in quality, honestly. So sometimes we'll be saying, hey, we want to take this map layer and put it somewhere, but we don't actually know what the lat long is, or it's degraded too much for us to know. So we've used some advanced AI techniques. We tried about, I think, 5 or 6, and eventually settled on super resolution, like a GAN technique, to upscale the text on documents so we can extract this useful information. So whether it be lat long or something like that, so we can actually place a map, or whether it's just the legend of the map or various other information of the map, we upscale all of it, then store all of it. So we're going to store all the associated metadata. So you can, 1, query, get where something is, and 2, get all the associated metadata that's part of that as well. And this is an example of, hey, once we've gone through and extracted said map layer, we're able to take that, combine that with the lat long, and then put that into another platform, whether it be Prospector or ArcGIS or whatever third-party map layer you have. We're able to do that directly. And finally, one thing you may be thinking is, okay, yeah, this sounds great if I just have one PDF, but my organization has hundreds or thousands or many tens of thousands of PDFs of images. And how scalable is something like this? So in our test pilot, working with OpenMine.AI and Prospector, just with a computer with a singular GPU, we were able to process 46,000 images per hour, or over 100 gigabytes of data per hour. And imagine if you simply just get another computer. So you have 2 GPUs and 2 computers, you're able to accelerate this by 2x. So this is a process that obviously, depending on the compute level that you have available, and as well, this solution can be deployed to cloud environments or on-premise or whatever works for your team. You're able to rapidly scale this to whatever processing levels are required for the size of your data set and the complexity of your data set. I'll hand it back to John. What's up?
Yeah. And so just to wrap up, right, and we're really excited about this partnership with Striveworks because we at Prospector are bringing together a lot of the mining industry expertise, the data aggregation and preparation that we do in the language side with a searchable data system to start from. Whereas, Striveworks, it complements us in this way where we have the enterprise scale machine learning platform to add to our repertoire with OpenMine.AI, and then have the data fusion and model auditability and data lineage and monitor and train and redeploy models. And at the end of the day, right, we're creating a platform here where it connects private and public data out of the box, ML hosting, no code training, and advanced data science tools, right? So we're really excited to share this with you all and really look forward to interacting and talking more about your own personal use cases. And from here, I think what we'll do is open it up for questions, right, Emily?
Yeah, absolutely. And I know we've got some in the comments, but also feel free to send them in now. And if I look distracted, it's just because I'm on the live LinkedIn stream on the other side. We've got a question, Jess said, from Cesar. From an internal deployment perspective, once it's considered complete, do you publish it to make it public? So I think maybe, Cesar, you mean like, does the data ever get exposed publicly? Let me know if that's not what you mean by that. But John, to clarify, like when these models are pulled into a company's proprietary data environment, like it stays within that, right? So
it stays within the company. The company is going to keep those results of those insights. And there's multiple options that we have to set up, right? One is, we have some cloud infrastructure that we can kind of rely to host things on and work with the data, but there's also the ability to kind of place on your own infrastructure as well, so that everything kind of stays in place, so that even the insights from that are coming back to you. They're not getting published out to the broader platform unless you choose so, right? Which is an option, but obviously we understand the necessity for confidentiality.
Yeah, and you can also, we can talk to you more about how you can even set up controls within that environment, right? So obviously, even amongst teams within a company, there are different types of data access that you want folks to have, and none of that's an issue. Part of why we worked with Striveworks to create OpenMine.AI is we recognize that companies are really sensitive to using a lot of the other tools that are out there, because even with a ChatGPT or Anthropic, you still have to send data to those platforms in order to get a response, right? That's what's a huge differentiator between those kind of, the platforms you hear all about and stuff in the media, or maybe you've played around with OpenMine.AI. You don't have to send your data anywhere else in order to leverage the technology. It all stays within your environment.
Yeah. And to speak to that, like from a platform perspective, like there's full auditability, data lineage functionality within it as well, so that you can actually ensure, like, at every stage of building out that model, who was involved in it, what versions of the model were created, what data sources were used in order to develop it, so you can actually functionally ensure that no public sources that are unwanted were used, or in the same scenario as a kind of audit that they never, were released out to a public platform as well.
We got a question. Do we ingest public geology data from the geological surveys? John, I wonder if you want to take this one. I had commented back that we're excited to do that. We can talk certainly more to folks about that, but do you want to explain what that might look like, or how we?
Yeah, and so we do some at the moment, right? And it usually goes into how we curate our own projects data in our data sets. But what we're trying to do is actually go systematically survey by survey, and that's the intended purpose of the sort of data aggregation part of OpenMine.AI. And part of that process is also to deal with some of the normalization issues, right? So dealing with making data compatible. So if we're looking at mineral occurrences that are coming in from the US Geological Survey versus the BC Geological Survey versus the Western Australian Geological Survey, we can kind of create that occurrence data in a normalized way that can be used consistently. And then on top of that, leveraging some of our techniques to as it relates to sort of mapping and going through and identifying projects that are already being tracked by the geological surveys, and tying that into our data using AI, right? So we use a technique in natural language processing called name entity recognition, which is where in a lot of documents we'll look to recognize a particular mine or when that's being talked about. And then we then compare that to mines that we already track, right? And we use a process where you basically take that name of a mine, you can convert it into a series of numbers called a vector, and compare that to other vectors of projects that we have. And then based on the similarity, we do matches. And if it's a high confidence, we then associate that. If it's a low confidence, we send for a human to review. And so with geological data, this is something we plan to do, looking at everything from geoassay logs to tenement maps, to mineral occurrences, resource reports, assessment reports. The intent here is to create a curated data set where you can kind of go for any geological surveys, publicly available data, and have it normalized for you in advance.
So that's one question I got on the side, John, was are there any file types or data sizes that we can't use this with?
Not at the moment. So we've dealt with some assessment reports and technical reports upwards of 1,000 pages or more. What we try to do is set up the models so that they run in a loop, and then it's a matter of what kind of processing power we want to apply to it. And this is kind of what Andrew was referencing before, right? We can go the 20x speed, or we can go the 2x speed. It all depends on how much data you want to look at and how fast you want to go. And then it becomes a function of economics. As far as file types, we already deal with XML, HTML, PDF, text-based documents, PowerPoints. We're able to we have our text extraction methods that deal with that. And then, from other files, as far as geospatial files and such, right? This is ways in which we are extracting the metadata out to do some organization on it, but also to normalize that. And so that is the long-term intent of the platform, is to be able to deal with any sort of file type. Obviously, there are some that are going to be more challenging than others. But the idea is to create something that is very normalized and a lot easier for you to use. Even if you're just using ArcGIS and you just want to pull in a bunch of different layers into your ArcGIS from a, say, WFS feed, that's something that we are adept and have done in the past, as well as Striveworks.
We've got a question from David. Are we focused only on exploration, or do we also look at other phases in the project lifecycle?
Yeah, so we look at all phases of mining projects. We actually we track all publicly traded companies producing assets globally. So we are doing quarterly and annual tracking of their production. We look at the very early stage, from the time that maybe someone buys a piece of land or gets access to it, to the drilling results, and all the way through to the life of mine plans, and then up into production and resource estimation. So we try to cover them through the full life cycle. And the intent here, right, is to establish curated models that can be used for different types of use cases that occur at different stages of the life cycle of a mining project.
Yeah, and I think a really good example of that was we got some questions again about like processing methods and the ability to look at flow sheets, right? Process large volumes of documents and pull out images of flow sheets and categorize those by different things. And certainly I know, David, you sent a follow-up note that you're looking at like project control components. And so absolutely, I mean, the same tech and the same kind of process can be applied to data that's used and collected at any stage in the process. And I think, again, one of Striveworks' strengths is like the kind of underlying capability and technology is used in incredibly, kind of live environments, right? It's not just for kind of fixed like academic documents and stuff like that. We got a question about languages. What languages are supported? At the moment, right, we are looking at different open source models. We actually rotate through different ones, whether those be open source or some of the closed source like Anthropic, Cohere, and OpenMine.AI, as well as the Llama 2 and Mistral. I think he means like like English, Spanish?
Yeah,
Yeah.
no, that's what I'm getting to.
Okay, sorry.
And so most notably for embeddings, right, when we're doing vector comparisons, we do like to use Cohere's 100 language multilingual embeddings for the way that we pre-process publicly available data. There are other open source models where we're looking at those different languages, right? The intent is to use that vector approach when we're talking about annotating documents and going through and doing translations to support that. We do fine-tune models, right? We ourselves are not in the business of fine-tuning languages into models, right? But the intent is to use those open source models and then refine them for geoscience specific needs as seen fit. But we do particularly like, from an embeddings model, when we're dealing with public disclosure data, using Cohere's 100 language multilingual embeddings models.
And really quickly, just to speak to like Striveworks under the hood, like we're with our MLOps platform, we're able to support any type of language. I've actually seen some models that were built recently by someone on our team. I was doing some like Chinese text translation in order to like extract some insights and combine that with some English language stuff as well. So yeah, something we've done before.
Yeah. And that typically works is, they're getting fine-tuned and localized, right? So that again, that's the idea of not having to send your information, and it's particularly why the open source models are great for your own private data. But oftentimes they don't have all the capabilities that some of the closed source models like Cohere, Anthropic, and OpenAI. From a models perspective, I think I've mentioned it. I just saw a question there. Yeah, we do use GPT models. For some stuff, we do use Cohere, we use Anthropic, we use Mistral, we use Llama, and then there's a series of other open source models which we fine tune and localize. And also Google's BERT models are a big fan of ours that we've used for a while, and getting a little excited about versions of Gemini that might be able to be localized and on own environments with their what do you call small bit models, right? The 1-bit models for specific use cases.
I think also just to note that if you want to better understand how the different LLMs and Gen AI is used in different parts of the process and where company data is exposed to that versus how we have it built into different functions, that's again why we really encourage you to fill out that form at OpenMine.AI, and we can take you through in detail, because I know different companies have different policies around some of those different tools and how it's exposed to your company's technology, infrastructure, and data, and everything is built with that in mind. So we leverage as much we can the best of what's out there, but we always do it in a really secure environment. We got a question: do you provide opportunities for privately held companies to expose data about their projects through your platform? And the short answer to that is yes. If you just shoot me a note, I can kind of provide more clarity on that and how we can build that in. We do not scrape data. We don't pull in private company data or even information from public company websites or other sources on the main Prospector platform. Like, it all comes directly from an exchange. We license the data from the exchanges. So we're very careful about that. But if you would voluntarily like to provide your data so that it's incorporated, we can absolutely do that. And just shoot me a note. We can line up a time to talk about that. What about JORC, SK 1300, and NI 43101 requirements? 43101s are my favorite. John, how about you? No. You want to speak to that?
Yeah. So we. We're typically looking to use these as a big component of how we collect resource and reserve data, as well as assay results data. It is actually a big component of how we classify data that comes across. As far as normalizing it, sometimes it becomes a bit of a challenge, but they are close, right? We're seeing, I think, definitely with the SK 1300, you're seeing a lot more technical reports being filed under that standard than versus the 43101, where but a lot of times they're being sort of dual. They're very similar and they're alike. But as far as resource and reserves, we do adhere to how we collect data. We always cite to a page and to a document when we're collecting it. When we're dealing with resource and reserves, we're always indicating whether it's inclusive or exclusive, right? So For instance, with the SK1300, everything needs to be exclusive. That's not the case with the 43101 or with the JORC. And then also with the JORC, there's not a report standard. There's only a reporting standard, right? So there's not like a standard report that comes out. So we have to actually monitor a lot of stuff. We spend a lot of time designing AI models to kind of pick up these documents and help us process them. It is sometimes challenging, right? But it is helpful. There are advantages, I would say, to each one of the three, right? Where we notice from data collection standpoint, there are things that are easier about the JORC than there are other things that are easier about the 43101. I think the big thing that I like about the JORC, just to maybe pontificate a little bit, is if there is a drill result that's released, you actually have to give your whole assay table on the ASX. And it's not a requirement of 43101. So I do like that about the JORC standard.
John, your preference is always for more data.
Yes.
Possible.
Well, if we want to, I always feel that, giving a few highlights needs to be given in the context of everything else you've drilled. So.
Box. Yeah.
That's me.
That's okay. That's all right. 43101s are still my favorite, even though CDAR is still, still go to Prospector, not CDAR. But Jess is pulling up the website here, or maybe you are, John. So just showing again where you can go to get more information and fill out. There's a form coming up anytime. Here we go. So if you want more info, just fill out here. And if you just click on the different boxes about what it is that you're interested in and kind of where you are in the AI exploration process, that'll just help us internally make sure that we've got the right folks on that call, on that follow-up and demo, so we can really dive into what it is that you're looking for and make it really efficient for you. So you've got all the experts you need. And yeah, we really look forward to hearing from you. I've seen a few already come in, so thank you guys so much. Thank you all so much for joining us live, sending in your questions and filling out those sheets. And we'll hang out for a few more minutes if there are any more questions, or if anybody wants to hear Mark sing karaoke, we can fill out the hour with a little Garth Brooks.
I mean, that's what I want. I don't think it's going to happen, but
you just need
a bottle of bourbon.
That's right.
We got to do an episode of On the Rocks for you, Emily, and then you might get that chant.
Karaoke on the rocks. Yeah.
Yeah.
We just need enough awkward silence, and then you'll just start singing.